Hi, I'm going to show you today a very cool analysis provided by the Massachusetts Institute of Technology's program for applied machine learning and AI. We're going to look at a data set on a number of restaurants in New York. You have to imagine that you're hired as their data scientist, and you're supposed to help them understand a little bit more about the demand, customers' preferences, because they're keen to improve the business. So that's what we always start with. That's the objective. Here we get the data from a food aggregator company, and they have gotten data from their registered customers in their online portal. They want to analyze this data to get a fair idea about the demand of different restaurants, and they hope to enhance their customer experience. So that is your job. We get started with a data dictionary as always. So we want to understand here what are the different columns that we have. You will have order ID, customer ID, the unique identifiers for the order and the customers. You'll also see restaurant name, cuisine type, cost, day of the week, so whether or not whether the customer ordered on weekdays or weekends, the rating, food preparation time, and delivery time. We always start with importing our required libraries, such as numpy, pandas, matplotlib, and seaborn for visualization. And then I also always like to use the import warnings functions to not get annoyed with any warnings. And in order to mount our data, which I stored in G Drive, I'll use the mount function here. So this is very important if you have also stored your data in your G Drive, and then you just copy the path in your G Drive, which you can do here in Google Colab over this really nice little file icon. You can go to Drive. I've had my data in here in AI and machine learning. You can go then to the exact file and just press, for example, here to the right and say copy path name. That is exactly what you just copy in here. Once you have that, you can print the 5 top rows, which the head function. So this is our data frame. That's the head function. You get the first 5 rows. You can see that each row corresponds to an order made by a customer. As said before, you have the different restaurant names, cuisine type, etc. in here. You want to first show how many rows and columns you have. 1,898 rows and 9 columns. You also want to understand the data types. You can use the .info function for that. And then you're also asked here to find any missing values in your data set. Luckily, we don't have anything. Next up is that you want to do a statistical summary. I always used to use the describe function here. I use .t for transpose to show a better visualization. So I have all the columns on the left-hand side, and then all the corresponding values from the statistical summary on the right-hand side. So this just enhances readability for me. Transpose just switches rows and columns. Then you should get the minimum, average, and maximum for food preparation. So again, here you can just say a new variable that you can call summary, which calls the food preparation time column from your data frame. And you just want to describe the data from this. And because you only are interested in min, mean, and max, you can make 3 different variables for that and then just print them out. So then you have your answer here with minimum food preparation time 20 minutes, average 27.4, and maximum 35. Next up is you want to see if there's any orders that have not been rated. So you can use the value count function here because that will give you a count of all the values in the categorical column rating. And you will see here not given appears 736 times. You can print it out and then you have your answer. Next up, we'll start with our EDA, our Exploratory Data Analysis. We always get started with the Univariate analysis. Here the question is to explore all the variables and provide observations on their distributions. So we'll use a set of histograms, box plots, and count plots. I always like to start with count plots, quite easy. I am first interested in the demand side by different restaurants. So I will be printing out the top 20 restaurants by order count. For that, I make a variable called top n, set it to 20. I will be looking at top restaurants, so I call my data frame, the column restaurant name. I use value counts to get the count of all the individual restaurants in that column. And then I will only get the top number here, the 20 that I want to have in there, and .index to get all the values on the left-hand side. I'll use, from the Seaborn library, I'll use CountPlot to just get a nice count plot and then print out the result. So here you have your nice visualization. You can see that Shake Shack is mostly ordered, and then meatball, and then blue ribbon sushi. We can do the same for cuisine. Here we see the cuisines that are most popular. American, Japanese, Italian are the 3 most popular cuisines. And next up, we can do a histogram for a numerical variable such as cost of the order. The cost of the order here we can see has a bit of a funky distribution. It's slightly right-tailed with orders that vary from like $5 to $35. So that's what you can see here. I set KD8.true, so you get also the nice density line in here. I'm also interested to see if orders differ between the weekends and the weekdays. So I'll just use the count plot here once more and just set the x-axis to day of the week. So then I get the count of the order by day of the week. You can see that weekends is almost double. The people will have more time, more hungry on the weekends than during the weekdays. Also, we can do a count plot for another categorical variable called rating. Here you see that not given appears, interestingly, most of the time, followed by 5, 4, and then 3. To understand a little bit more about food preparation time and food delivery time, we can do some box plots. It's especially important to understand if customers value quality of the food, which would, for example, show in a higher food preparation time. We can see here that we have a very normal distribution. The mean here is very much in the middle, no outliers. So the food preparation time shows a normal distribution with no outliers ranging from 23 minutes to 31 minutes. We do the same for the delivery time. Here we have a slightly left skewed distribution. We can see that because the mean here is a little bit to the right. No outliers, nice at the quarter range, so all good and dandy in this one as well. Then we're asked to show the 5 top restaurants by number of orders received. We can always get that by using the group by function. So I'm using group by the restaurant name. I want to count the order ID, and I want to get the 5 largest, print it out, and then voila, I see that exactly what I've seen above already. Shake Shack is the most popular, meatball, and then ribbon sushi. Next question is, which is the most popular cuisine on weekends? So what we do in order to answer that question is we will first filter our data frame for the values weekends, which are in the column day of the week. So I need to filter, so I need to use basically here double the square brackets to filter the data frame and only get those get the data for those orders where weekend appears as true in this column. And then we need to group it by cuisine and count the order ID. So we use again the group by function on this new data frame that we just made, weekend order, which is this one. We group by the cuisine type because that's what we're interested in, and we count the order IDs. That's what we use the count function for. Then we use the 5 largest interested again, and we can just print it out. Again, the top cuisine on weekends is the American one. That was the answer to question number 8. Then we're also interested in what percentage of the orders cost more than $20. Here already I can see that we need to use a filter because more than $20 is definitely some filter that we need to use. So I just make a new variable, call it above $20 US. I need to filter on which column, on cost of the order. For all the cost of the orders that are above 20, those will be reflected in this variable now. And then we can perform a function on this new variable. We want to get the sum of all the orders that are above 20. And then we want to calculate the proportion. How do we do that? We take the count of over 20 orders, divided by the entire length of the data frame. That will give us a fraction of those orders for which that is the case. And then we just take it times 100 to get a percentage and print it out. Et voila, almost 30%. Next up is what is the mean order delivery time? Here we just perform a function mean on the column delivery time, pretty straightforward. Question number 11 was the company has decided to give 20% discount vouchers to the top 3 most frequent customers. Find the IDs of the customers and the number of orders they placed. What we want to do here is use the group by function on customer ID to be able to find those orders that are the largest. So very simple. We group by customer ID, we count order ID, take the 3 largest and print it out. So these 3 customers make most of the orders. That's what we get from here. Then next up, we have finished our univariate analysis and we go over to multivariate analysis to understand a bit more about different columns in reference to one another. First, I want to understand more about the demand on weekends versus weekdays by the cuisine type. So I'm interested if that customer preferences switch here during the weekend, for example, if all of a sudden they like Italian food more than during the week. So I'm using the group by function and using a set of functions on the grouped columns. So I want to group here by cuisine type and by day of the week because that's these 2 variables that I'm interested in. And then I will perform an aggregation, one on the mean demand by order ID, count the order ID, and the mean price. Of course, this is cost of the order, and then I'm interested in the mean. Always for comparisons, I always use mean. I reset the index to be able to make a nice pivot table, and then I can pivot the data for better plotting. So now I have a pivot for the demand and for the price. And here just basically tell it for the pivot, please use the index cuisine type, use the column day of the week, the values mean demand. That's the one that I just defined up above here. I do the same for price. And then I want to plot the entire fun part next to each other so it's nice and readable. Here I plot the mean demand plot. So here I'm using a Barplot. And then I'm just setting the title, the Y labels, the X labels, and also making a nice little legend here that goes here in the corner. And then I just use type layout to have it nice and next to each other, and then use plt.show to show the graph. So basically here you can see the mean demand per cuisine type on weekends versus weekdays. Interesting. The American cuisine more than doubles on weekends. Same for Chinese and for a lot of the others here as well. That's true for the demand. However, the price is not really that much different. It's a little bit higher on weekdays, interestingly, than on weekends. For some of the cuisines, here the most popular one was the American one. There on weekdays, the price is a little bit lower than doing weekends. But we can already see there might be an opportunity because people still prefer American cuisine on weekends. However, price almost stays the same. So probably something that we could optimize there. Then we're interested to understand the correlation between different variables. So here we just use a correlation matrix. What I'm doing is I am selecting the variables that I'm interested in. So I'm using order count. I want to use the sum here, food preparation time. I want to use the mean, delivery time, also the mean, cost of the order, also the mean, to be able to compare. And I am grouping all of this by cuisine type. And this will give me a nice correlation matrix that you can see here. So I will be able to understand the correlation matrix, including the order count. You can see one of the higher correlations here is between order count and food preparation time. So there seems to be some correlation between quality of food and the number of orders, as well as, well, delivery time, not really, very small correlation. But small, like little correlation here, maybe between food preparation time and delivery time as well. So we can make a conclusion and say, based on this heat map, it seems that there is a moderate positive correlation between food preparation time and the cost of the order. So again, here, cost of the order and food preparation time. So it looks like people are willing to pay maybe a little bit more for better quality food. And then that is our observation. Next up, we are looking still on the demand side. Here we look into order preparation and delivery time by cuisine type. So very similar, I'm using group by function on the column cuisine type. I count the unique order IDs, reset my index by order count, do something very similar for order counts by vaccine. And then what I'm doing is I'm using here a set of Violin Plots to help me understand how the mean food preparation time by cuisine time differs. And I've ordered it by the demand. This is quite nice because it helps me to understand here on the y-axis the average food preparation time in minutes, the type of cuisine, and that then gives me a nice overview of where does it actually take the longest to prepare the food. So where is quality the highest, ordered by the count of the orders. So we know that American was a very popular cuisine here. Very consistent food preparation time, no outliers. It's pretty consistent. So apparently customers also value that. They want to have predictability. They know my burger will arrive in X amount of minutes. I don't have to wait any longer. Same for Japanese and Italian food. Versus like some of the others here, you have quite a skewed distribution. We then also do the same for delivery time. The most ordered cuisines here, again on the left-hand side, delivery time is a little bit higher, interestingly, for some of the most ordered cuisines than for some of the other ones. Here it becomes very, very hard to say if there's a correlation or not, but apparently that's not as important to customers. Then we do a set of box plots to understand price sensitivity. So we are interested here in the cuisine types by cost. So we count the number of orders for each cuisine type first. Again, we use value counts function on cuisine types. We use the index, and then we understand here the relationship between cost of the order split by the cuisine types and ordered by the number of orders to understand demand for different cuisines and willingness to pay. So here again, the most popular cuisines, American, Japanese, and Italian. The cost of the order, as you can see, is everywhere pretty low. It's not a normal distribution, as we've also already discovered above. Willingness to pay seems to be a bit higher for like some of the other cuisines here, the Thai one and the Mediterranean one, maybe also the Spanish one, but they're not ordered as often. So we can make a conclusion that here the relationship between the cost of an order split by cuisine times, we would like to show here how much different customers are willing to pay for various types of cuisines. Here we can see that the cost of the three most ordered cuisines, American, Japanese, Italian, are distributed similarly with a slight right-tailed distribution, indicating a similar willingness to pay between US dollars 14 to 22. Already as mentioned before, the Middle Eastern cuisine shows a few outliers. A few customers are willing to pay between 30 and 35 US dollars. So the Middle Eastern was, I think it's this one. No, this one here, exactly. So here are the outliers where some customers are paying way more. Yes, and then we see that customers with a preference for Korean and Vietnamese have the lowest willingness to pay with 13 US dollars on average. Nice. So we want to understand the price sensitivity a little bit more after discovering the price sensitivity here already a little bit by cuisine type. What we're doing here is grouping the data and summing the cost and the count of the orders. So I'm grouping the data by day of the week, by the cuisine type. I'm aggregating with the function sum and count. Sum for cost of the order, count for order ID. We set the index, and then we want to plot it using Seaborn with a line plot. And we want to have on the x-axis the order count, on the y the total cost. And I'm using Hue to show the difference between the days of the week. That will give me a relationship between total cost and number of orders per customer. So as the order count goes up, total cost goes up as well. That means that we have a perfect correlation between price and demand, which is quite surprising because that's not typical market behavior. Normally, price and demand have an inverse relationship. So as price increases, demand usually decreases. Here, that is apparently not the case. So that means that actually people that order more are also willing to pay more. It could be that here, like higher spending is associated with higher frequency of orders. That means that customer might be loyal to certain cuisines regardless of the cost. That's a very interesting finding already. We also look here into average rating by cuisine type. Not so interesting if you ask me. Also no correlations, completely random. The average rating and the number of orders doesn't really correlate. We do the same on the demand side still. We're trying to understand how do rating and delivery and food preparation time correlate. We can see here through like a one of these like little line plots here that a higher rating seems to be correlated with delivery time between 24 and 24.75 minutes. So here's the highest rating, 5, that has a little bit lower delivery time, but also not much lower than no rating at all. So cannot really say anything about that. This is the same for the food preparation time. Rating of 5 is almost the same regardless of like how fast you were. So we can say the mean food preparation time does not seem to influence the rating much. This is quite surprising. I would have thought that higher rating is either higher food preparation time for high quality, or for the customers that really, we could maybe also split this a little bit and see like how do different cuisine types influence that preference. I would assume that those customers that we've seen and have a high willingness to pay, they also they value more the quality of the food. So we would see a higher food preparation time. That's an additional analysis that we could do. Last question that we're going to look at is the company wants to provide a promotional offer in the advertisement of the restaurants. The condition to get the offer is that the restaurant must have a rating count of more than 50 and the average rating should be greater than 4. We need to find the restaurants that fulfill this criteria. So what we do here again is we need to turn the rating column into something numeric so we can play around with it. So that's what we do here in the beginning. For the rating column, we basically replace it and we replace not given with just absolutely nothing. And then we group by restaurant and use the aggregate function to calculate count and average. So we make a new variable here called promotion. That's the data frame grouped by restaurant names. We perform a set of aggregate functions. We use count for rating, mean for rating as well, and reset the index. And then we want to look for those promotions where the condition is true, so where the count of rating is above 50 and the promotion average rating is above 4. So we can just use a nice filter function here and call it promotion filter. And then we just apply that filter to the restaurants with enough ratings. That's this one. Do the same here, and then we can just display the results. And then you will see the restaurants that actually fulfill the conditions. It's like Blue Ribbon Fried Chicken. They have a count rating of 64 and an average rating of 4.3. And there's a couple of more questions that I won't go into detail, but you can read along, also read through the conclusion and the recommendations. And yeah, leave me some comments what you think about the analysis. If you have any questions, don't hesitate to reach out.